Bismillah, Alhamdulillah, Salatu Wassalamu ala Rasulillah. Welcome everyone. Today we'll be looking at the implementation of a singly linked list. So in a singly linked list, we have elements and each element has two parts in it. First is the value part and second is the next part. So this value part will contain the value for the element, like suppose an integer value or a character value, and the next will point to the next element in the linked list. So this complete is a linked list, and each element, this is the first element, it has its own value, and the next pointer will point to the next element in the linked list. And there is another pointer which is called first pointer. So this first pointer will always point to the first element in the linked list. So this is the linked list and this is the first element, so this first pointer is pointing to the first element, and the last pointer will have the next value as null because it is the last element in the linked list, as there are no elements in the linked list. So the last element will have a next value equals to null. So now let us look at how we can implement this singly linked list in a C program. So basically what I am doing is I am representing this node structure of a linked list element using a structure type. So int a defines the value part of the element. So I am using an integer variable to store the value. So I am storing integer values in this linked list, and this struct node star next represents this next pointer, which will point to the next element in the linked list. As the next element is also a node, so the pointer type should be of type struct node star. So this is the structure which I am using to represent a node or an element in a linked list. Now let us look at the more implementation details of this singly linked list. So I am just using a infinite while loop. Initially I am creating a first pointer and I am initializing it to null, because if there are no elements in the linked list, then your first element will automatically be null. So this first equals to null indicates that. Now I am using a while loop, while one infinite while loop, and in this while loop I am asking the user to enter their preference to insert an element in the linked list or search for an element, delete an element, display list, or exit. So when the user presses 5, so the program will exit. Now I am using a switch case to handle this various choices of the user. So in the case 1, I have to insert an element in the linked list. So I am asking the user enter an element. I am then scanning that element. As the element is an integer, I am using a %ld and storing it that and %key is an integer. So I am then inserting this key into this linked list which is pointed by the first. So first will point to the linked list, first element of the linked list. So I am inserting the key into the linked list. So we'll come down to the insert function. So here is the insert function. So I am passing the first and key. So the first pointer will be stored in this pointer x. I am using another pointer p to, this will be the use of this will be explained in the coming minutes. So I am checking whether this p is equals to null or not. This p equals to null indicates that there are no elements in the linked list. So if there are no elements in the linked list, then we create a new node using the malloc function. So this malloc function will allocate a memory of size struct node. Struct node is the node in a linked list. So I am then assigning the key value to the data part, the value part, that is a. A is used to store value, and the next, as it is a single element in the linked list, because p was already null, so this is the first element in the linked list. So I am just making the next value of this node equals to null. So this will, for the first element in the linked list, this will execute because the p will be null as the first is already null. So I am allocating a new memory for that first node. I am assigning the data value as key and the next pointer as null because it is the only element in the list. Else, which means there are already some elements in the list, one or more elements in the list. So I am traversing to the till the end of the linked list, while p arrow next not equals to null, p equals to p arrow next. So suppose this is my linked list and p is pointing to this element. So while the p arrow next is not equals to null, I can traverse to the next element. So I am assigning p equals to p arrow next, which shifts the p from this node to this node. Then again p arrow next is not equals to null, so it will move like that till the end of the linked list. And this here at the end of the linked list we have p arrow next equals to null. So the p will come and stop at this point, and then we are creating a new node for p arrow next, and then aside moving to that new node p equals to p arrow next, and then assigning the key and the next pointer, initializing those values. So the value will contain the key, p arrow a is the value which will contain the key, and p arrow next, as it is the last element in the linked list, it will be equals to null. So then I am returning this x. So why I am returning this x? Because suppose sometimes there are chances that in the modified version of the linked list, single linked list implementation, sometimes the user may want to enter at the beginning of the linked list. So at that time the beginning node may change. So for that you need to return the first node of the linked list. So that's why I'm returning x. So we have inserted an element into the linked list. Now suppose the user wants to search for an element in the linked list. So I'm just asking the user enter an element to search. So I'm scanning that using scanf, and then I'm using the search function to search for that element. So in the search function, first I'll point to the first element of the linked list, and then I'm start from that. While p is not equals to null, until p not equals to null indicates the end of the linked list. So until I reach the end of the linked list, if p arrow a equals to x. So p arrow a is the value part of the linked list, a linked list element, and x is the key that I want to search. So if p arrow key a equals to x, then return 1, which means the element is found in the linked list. Else move to the next element. So we move to the next element until we reach the end of the linked list. So if we reach the end of the linked list, then you can just return 0, indicating that the element is not found in the linked list. So in the main function, I'll just check if I equals to 1, then element found, else element not found. Now coming to the next option, that is delete. So I'm asking the user to enter an element to delete. I'm reading that element using scanf, and then I'm calling the delete function. So in the delete function, first I'm using this temporary pointer x. Now if the element which the user wants to delete is at the first of the linked list, at the beginning of the linked list, so I'm just checking whether first arrow a, which means the value part of the first element, is equals to key, then I will shift this first to the next element, because if I delete this element from the linked list, then this element will become the first of the linked list. So I'll just assign first equals to first arrow next, which means this node, and this node then can be deleted. So p is pointed to this node because we have first assigned p equals to x. So p will be pointing to this node. I am moving first to the next node, first equals to first arrow next, because this node will be deleted and this will become the first node. So I am then using free function to delete this node. Free p will delete this node completely, and then I am returning the first. This will be the new value of the first, so that I have to return to the main function. So I am returning first. Else means if the value that user wants to delete is not the first element, then we are searching for that value in the linked list. While p arrow next arrow a not equals key, p equals to p arrow next. So this loop will execute until and unless p arrow next arrow a equals to key. Now consider this example. So this is the linked list already which we have created, and the 99 is the element which we want to delete. So we are checking p arrow next arrow a not equals to key. Suppose I want to delete this element, so I have to stop one node before this element, because this node is pointing to this node. So if I want to delete this node, and I have to change the value of this next pointer to this node, because once we delete this node, then we cannot access this node, because this node is accessed through the next part of this node. So before deleting this element, I'll first reach this node. I'll get the value of this node using the next value of this node, and then we can delete this node. So this while loop will repeat until we reach this node, the node before the node which you want to delete. Then I am creating another node, q equals p arrow next. Q is pointing to this node now, and p is pointing to the previous node. So p arrow next equals q arrow next. Q arrow next is this node which is the remaining nodes of the linked list. This is the node which I want to delete. So I am just changing the pointer from this link to this link. So this is the node pointed by p. P arrow next is equals to q arrow next. So I'll point to this node now. So I can now delete this node. So free q and then return x. So this is the way how we can delete an element from the linked list. And then the last function is just the display function, where I am going to display the list of the elements in the linked list. So in the display function, so I am just displaying linked list is, while p is not equals to null, I am just printing the element p arrow a. It represents the value of the element node, the value at the element, and then after displaying that node I am moving to the next node. So until the next node is not equals to null, I can display the values. So this is the implementation part of the singly linked list. Now just we'll try to run this program. So we can run this program using, first we'll compile this gcc space single linked list.c minus o space single. So I'm just compiling this into an object file single, so I can execute that using /single. So as I have written a while loop, so this in this program I will be asked to enter my choice, either to insert an element, to search for an element, to delete an element, display list, or exit. So until I press 5, this program will be repeating in the while loop. So first I want to insert some elements in the list. So I'm inserting, we'll insert this same program, 12, 99 and 37. So 12, and then again I'm inserting another value, 99, and then inserting 37. So I have created this linked list. Now we'll just search for the elements whether they are existing in the list or not. So I'll search for 99. So element found, as it is already there in the linked list. Now we'll search for some other value, 1. As the one element is not there in the linked list, I am getting element not found. Now we'll try to delete an element 99 from this list. So we'll use 3 to delete an element 99, and then we'll search for that element again. Search 99. As 99 is already deleted, it is not found in the linked list. So I press 4, it will display the list. So this is the list of elements in my linked list. So if I press 5, then we exit or come out of the loop. So this is the way how we create a linked list. So structures are useful for creating a linked list because all the elements in a node are different. One is of integer type and another is of pointer type, pointer to a node, struct node. Hope you have benefited from this video. Assalamu alaikum warahmatullahi wabarakatuh.